Okay, let's return to Module 6, and we are now on Part 3, where we're going to talk about how to solve normal distribution problems. Given some variable x, which we will assume is normally distributed with some mean or standard deviation, how do we find probabilities on the variable x? Well, we're going to do this by converting the desired x values to their corresponding z values using the familiar z equation, z equals x minus mu over sigma. And then using our knowledge of the standard normal table that we talked about in the previous part of this module to look up the desired area. We will also later on look at how to do this with a TI-83 or 84 calculator. The second thing we want to do sometimes on normal distribution problems is what I refer to as a working backwards problem. Instead of finding a probability, sometimes you'll be given a probability and you'll need to find a value of a variable that satisfies some equation. In other words, you're looking for a value of x. So it'll be useful in this case to take this equation and simply solve for x. If you do that, you'll get the following equation. X is equal to z sigma plus mu, which basically says any value of x has to equal its corresponding z value multiplied by the standard deviation plus the mean. And we'll get to one of those shortly. Let's do a problem as an illustration of this, of both parts. Assume we have Joe's Diner, and Joe has found that the lunch bill, the mean lunch bill at his diner is about $18 with a population standard deviation of $6. So we'll treat these as the population mean and standard deviation. $18 is the mean, $6 is the standard deviation. And we're going to assume that lunch bills are normally distributed. And we're going to look at three problems here. What is the probability that a customer spends at least $27 for lunch at Joe's? What's the probability that a customer spends less than $12? And Joe wants to give a free dessert to customers who spend more than a certain amount for lunch. If Joe only wants 5% of his customers to get the free lunch, how much would you have to spend in order to qualify for the free dessert? Let's start with the first part. What's the probability that a customer spends at least $27? Let x be the amount spent for lunch. We want the probability that x is at least $27, right here. You're going to solve problems like that on a normal curve by converting it to the equivalent area on the standard normal distribution. Take the 27, subtract its mean of 18, divide by its standard deviation of 6, and you'll get the corresponding z-value here of 1.5. In other words, the probability we want that x is bigger than 27 is equivalent to getting a z-value bigger than 1.5. So now you go to your z-table, look up 1.5 in the positive z-table. You have to remember that the table is cumulative. It gives you all probability below that z-value, which in the table is 0.9332. But we want all probability above that z-value, so we will have to take the complement, that is, subtract that from 1, and we'll get an answer of 0.0668. We can see this graphically on the next slide. Here's x, the amount spent at Joe's Diner, with the mean of 18, standard deviation of 6. And we want this probability out in the end here. We want the probability of somebody spending more than $27. We take that value of 27 and we have to convert it to its corresponding z-value by means of this equation. You should see that that z-value is 1.5. Take 27 minus 18 divided by 6, you'll get 1.5. Why 1.5? Because $27 is exactly 1.5 standard deviations larger than its mean. So we go to a z-value of 1.5. If you look up 1.5 in your z-table, it'll give you all probability below there. But again, we're going to have to subtract from 1 to get the probability that we want. and that answer is 0.0668, as explained here on the previous slide. Let's go to the second part of the problem. What's the probability that somebody spends less than $12, x less than 12? Again, we will solve this by converting it to its corresponding value on the z-table. X less than 12 is equivalent to z less than 12 minus 18 over 6 is equivalent to z less than negative 1. Go to your negative z-table, look up negative 1, and the table gives you a probability of 0.1587. And that is the area that we want since we wanted everything less than it, and that's what the cumulative table gives us. That is the correct answer. Again, we can look at this on a graph. By the way, I encourage you to draw pictures of normal curves. It's a very good idea to draw a picture, put in the mean and standard deviation, and it'll help you see some of the answers that you want. It'll also help you avoid certain mistakes. Again, dollars spent on lunch, we want everything below 12, this red shaded area here. Convert that to its corresponding z-value by taking 12 minus 18 over 6. You get the z-value of negative 1. Go to your z-table, find the probability that z is less than negative 1, and you'll find it's 0.1587. Again, this is how you'll find all probabilities on normal curves. You're basically going to find the equivalent area on the standard normal distribution. Now let's go to the last part of the problem. Remember, Joe wants to give free dessert to people who spend more than a certain amount, but he only wants to give this to 5% of his customers. So we want to find a dollar amount spent on lunch that puts you into the top 5%. So we want a value of x that gives us the 5% of customers who spend the most. So that tells us that we're on the right side of the distribution. Dollars spent will be higher on the right. As I point out here, it's a good idea on these working backwards problems to always figure out which side of the distribution you're on first. Because if you're on the left side of the distribution, you have to remember to use negative z-values. We're going to use the equation x is equal to z sigma plus mu. Now we already know the mean and standard deviation. The mean is $18, the standard deviation is 6. All we have to do is find what I call the corresponding z-value to the x value that we desire. Since we want a z-value that leaves 0.05 probability above it, the cumulative probability below it has to be 0.95. So now you go to your positive z-table, but this time you look in the middle of the table, where the probabilities are. You want to find a probability of 0.95 in that table, and then look at the row and column you're in to get the correct z-value. This particular case, you're going to find two z-values, 1.64 and 1.65, where the probability of 0.95 is right in between those two z-values. We often interpolate this one and use a z-value of 1.645. You could have used 1.64 or 1.65, it wouldn't matter to me. You'll get answers close enough that'll be fine. But this particular one, most of the problems in your text, for example, for this particular probability would use a z-value of 1.645. So now we can plug everything into the equation and solve. X is equal to 1.645 times 6 plus 18 gives us $27.87. In other words, people who spend $27.80 or more are in the top 5%. Joe would probably round this to some convenient number, say $28, and anybody spending more than $28 then would qualify for the free dessert. Again, we can kind of take a look at this on our graphs. We wanted to find a value of x here that leaves only 5% of the distribution above it. We already know the mean and standard deviation. You just have to get the corresponding z-value that leaves 5% above it, which means 95% below it. So you went to your z-table, looked for 0.95 in the middle of the table, look at the row and column, and you'll find the z-value is 1.645. Plug it all in the equation. I just show you the calculation over here again. 1.645 times 6 plus 18 gives you the $27.88. Okay, now for those of you who have a TI-83 or 84, the normal distribution function is in your calculator, and we'll show you how to do these problems on your calculator. First, if you want to find a probability on the normal curve, press the second level button again, and hit the VARS button, which gets you into what I call the distributions list. Scroll down until you find normal CDF, which stands for cumulative distribution function. On my calculator, that's number 2. Do not use number 1, normal PDF. We will not be using that at all. So go to normal CDF and hit enter. The calculator is now waiting for the following information: the lower bound of the interval whose probability you want, the upper bound of the interval whose probability you want, the mean of the distribution, and the standard deviation. And all of these will be separated by commas, and then hit enter. So for example, let's say IQ scores are normally distributed with a mean of 100 and a standard deviation of 14. And we said find the probability that an IQ is in the range of 90 to 118. Using your TI-83 or 84, press second level, VARS, normal CDF, enter 90, comma, that's the lower bound of the interval, 118, comma, 100, comma, 14. Press your enter button. By the way, remember, do not put a comma after the fourth entry. After the 14, do not put a comma or you'll get an error message. So 90, comma, 118, comma, 100, comma, 14. Hit enter. You should get a probability of 0.6632. The calculator, by the way, might give you slightly different answers than using the standard normal tables in your book, because remember, your standard normal tables in your book only go out to z-values of 2 decimals. Your calculator can be a lot more precise than that. If you want an interval that does not have an upper or lower bound, enter a very large or small number. What I mean by that, for example, let's go back to the IQ example. Suppose IQs are normal again with a mean of 100, standard deviation of 14, and we simply want the probability that an IQ is 125 or higher. There's no limit on the higher portion of this. So again, our lower bound is 125, but our upper bound is basically infinity. Well, you can't put infinity into the calculator, but you can put some very large number. I often use 99 to the 10th power, which is what I use in this example. So press second level VARS, normal CDF, 125, comma, this is 99 raised to the 10th power, comma, 100, comma, 14. Hit the enter button, and you should get a probability of 0.0370. One other note. If you wanted to solve probability problems concerning the standard normal distribution itself, which has a mean of 0, standard deviation of 1, if you simply leave the mean and standard deviation off in the normal CDF command, the calculator assumes that you're working with the standard normal. As an example down here, for the z distribution, find the probability that z is between minus 0.62 and 1.37. We did problems like this in the previous part of this module. Once again, you could hit second level VARS, normal CDF, enter, put in minus 0.62, comma, 1.37, and don't enter anything for the mean or standard deviation, and the calculator knows that you want to treat this as the standard normal distribution, and it will give you 0.647 as a result. What if you want to work backwards on the normal distribution to find a value of x? Well, we can do this also on your calculator. Press the second level button, and again the VARS button, and the third thing down should say INV-NORM for inverse normal. This will allow you to find a value of the variable x rather than a probability. Now, the way you use this particular function is you first enter the probability less than the x value you desire, comma, followed by the mean of the distribution, comma, and then the standard deviation. As an illustration here, supposing I said 95% of people have IQs below what value? So I didn't ask you for a probability, I'm asking you for an IQ value such that 95% of the distribution is below that value. Press second level VARS, inverse norm, enter. You want 95% below this value, so you put in 0.95, comma. The mean was 100, comma. 14 is the standard deviation. You should get a result of 123.027. That is, an IQ of 123.027 has 95% of the population less than that IQ value, assuming a mean of 100 and a standard deviation of 14. Okay, so get used to using your TI-83 or 84 on these problems. Remember, on any assignments I give you that involve you writing out answers, I would want to see all of your steps that you put into the calculator as a result. And that's the end of part 3. And we've got one more part left to this particular module, which we will get to soon.